Okay, good afternoon, 6th period. Today is Tuesday, Valentine's Day. Happy Valentine's Day. February 14th, and you have a sub today. You can turn in 9-1 if you want to the sub into the basket on the table. But if you want, I will go over questions. It shouldn't be too hard, 9-1. 9-2, we're going to talk about domain and range. I'm assuming you guys talked about it last year, but it's always a confusing topic for people. Okay, so we will talk about it some more. Okay, so get out your yellow notes for 9-2, or note packet. Okay, and you should have picked up hopefully a worksheet, or the sub will give you guys a worksheet after the video. Okay, let's talk about domain and range. Okay, so first of all, domain of a function is the set of all values, which is basically our x, or the inputs of the variable where the function is defined. It's a big word, defined. Can't be undefined. Can't be imaginary. So we're going to put can't be undefined. And you guys should know what I mean by that. Or i's. I's are not real numbers. They do tell us things about the graphs, but they're not part of our domain. It's not numbers you plug into a function to find an output. Your range is your output, or your y of x's, and also it could be f of x. F of x is the same as y. And it's the set of all the values you get once you plug things in. Okay? So if you plug things in and you know, hey, the lowest number I can ever get is 5, then you know your domain, or your range is going to be greater than 5. So we'll talk about that. So range is kind of the output, and usually domain has a smaller limitations than the range. Okay, so that is all on your notes already written out for you. So let's go to example 1. Okay, so here's something like we did on the last test, which you guys did great on. I need to figure out what the domain is. Okay, so a lot of times, so you guys know, you could write this in, I don't care on this chapter if you write interval notation or just inequality, and I actually will do both just to show you. But domain excludes x values that result in the division of 0 because that is undefined. And we can't have undefined because as we go to graphing farther along, that's an asymptote and your graph never goes there. Okay, well, last chapter we factored a lot like this, and that would be x plus 2, x minus 2. And we want to figure out when that domain would equal 0. And remember in the last one we put open circles there. So x cannot equal -2 because -2 plus 2 is 0 and 0 under is undefined. And x cannot equal +2. So we put a line through equal sign means not equal. So you could write the answers this way. The domain is all reals. So that stands for all real numbers, except x cannot equal -2 or +2. That's one way to write the answer. Everything else would be fine. And we're actually going to graph things like this in chapter 11. And you can write it like that. If you like, you can think from last chapter and say, oh, I would have had an open circle at 2, and I would have had a closed or open circle at -2. And what would have happened is everything else would have worked. So if you want to write it, you get interval notation, because Miss Caldera's class, they probably will write like this. I think it's longer and just a little bit more to write. You could also write it like that, and that's interval notation. Basically saying, I could have everything, but I have an open circle at 2, an open circle, or -2 and 2, and that's like everything else will work. All reals means everything works but those two. So both answers are fine. Okay, so that's what happens if it's undefined. Division by 0 is undefined. Okay, let's talk about the next one. This is square root. So I know the square root of 3 or 9 is 3. Okay, when I solve, but the square root of -9 is impossible. I know it's plus or minus 3i, but that is not a real number or solution that you can plug into the equation. You can't plug 3i in there and get an answer. So the domain excludes values that result in even roots of negative numbers. And the reason why it says even roots, square roots, fourth roots, you can take a square root or fourth root or sixth root of a negative number. But you can't take a cube root of a negative number. Okay, so you're going to see that. Like the cube root of 8 is 2, and we talked about it, and the cube root of negative 8 is negative 2. So you can take cube roots. It's just even roots. So this is what you do. I can't take a negative, so I can take the square root of 1. I can take the square root of 0. Some people think you can't. It's 0. I cannot take the square root of negative 1. Not possible. So you would write your answer as x has to be greater than or equal to 0. And if you want to write this as interval notation, it's 0 to infinity. Both answers are okay. Okay? So, main two things we're going to talk about, just like the main two things for things to be not a function, is if you don't have a y, or if you have a y squared. Main two things that make it limit your domain: denominators and radicals. So on your thing, you're going to see a starred, and you said it should tell you the denominator cannot equal 0, and square roots must be 0 or positive numbers. Whoops, can't see that. Okay, main two things you're going to think about. The tricky part is when you have a square root in the denominator. So then it both things. We'll talk about that. Okay, so we're going to go through and we're just going to list the domain and range for things. Okay, so example 3. Find the domain and range. So this is just points on a graph. Not connected, not continuous, just points on the graph. If I ask you for the domain, it is just the x values because your domain is x values, and that would be the answer. I'll let you write it down, but that is just the answer. Just super easy. Okay? This is a function, going back and reviewing 9.1. For every x, there's a unique y. It's okay if you have the y twice, but you can't have the x twice. So it is a function. If you see numbers like this, try to put them in order in a set. Okay? This is called a set. And and don't list things twice, if there is twice, but it won't be twice. If I asked you to list the range, it would be the y values, and you wouldn't list 2 twice. Okay, let's go to the next one. Remember, the two things we're looking for, denominators and radicals. Number 4. People miss this on the test all the time. What's the domain? Well, does it have a square root? No. Does it have a denominator? No. So the answer for the domain, because we're only doing domain right now, is all reals. So you could write it like that. That means all reals. Or if you want to, you can write it like this. I don't care. Or you want to write both. That fancy R, which is kind of ugly right now, means all reals. So no denominator, no square root. I can plug any number in there. I could plug -1,000 in there and get an answer. Hard to graph, but I can graph it. Or I can get an answer. Okay, number 5. What do you see? Well, I see a denominator. What can't x be? Well, x can't be anything that's going to make that equal 0. So x cannot equal -5. So I'm going to put D for domain. So my domain would be all reals except x cannot equal -5. Or if you want to write an interval notation, it would be everything but -5. So it would be -infinity to -5, parentheses, union, -5 to infinity. Both answers are correct, whatever way you want to write it. Whoops, that's a +5. My bad. Oh, no, that's a -5. I'm right the first time. Overthinking myself. That is a -5. You write it. Because the only thing that doesn't work is -5. Because plug in -5, 1 divided by 0 is undefined. Can't graph it. Okay, so let's get one with the square root on it. Oh, actually, let's get another one with a denominator. 2 sets of denominators. Again, we're going to graph these in chapter 11. I have 2 values of x. I probably have 2 things x can't be. Well, in this one, it's 0. And this one, it's 5. So you would say the domain, you could write this 2 ways again, is all real, as it can't be i's, except x cannot equal 0 or 5. If you want to write interval notation, it would be this. You will be just using the parentheses at the spots that it can't equal. These mean exactly the same things. You do need to put all rows. Everything except 0 and 5 works. Okay? Okay, now we're going to get to square roots. Okay, so this is where this comes up from last chapter. Okay, I can't have this equal a negative because the square root of a negative has an I in it. Okay, remember that number 20, there's another one we did, but number 20 on the review, I said, don't even worry about the denominator because it would have an I in it and it wouldn't be on a number line. So I want to make sure that this inside has to be positive or 0. So greater than or equal to 0. Okay? So now up to you guys. I honestly would solve this and factor it and do everything and put it on a number line. So I'm going to show you guys that. So I'm going to move the 9 to the other side. So I have negative x squared is greater than or equal to negative 9. You could divide by, you could either move it over and factor it, or you can divide by negative 1. I could show you either way. So if I do that, I get x squared. Remember, you divide by negative, you flip the sign, which a lot of you guys forgot on the test, and then I'm going to take the square root. So this way is a little bit hard because you don't know if x is less than 3 and less than negative 3 because it's just a weird problem. If I would have factored it, and at this point, I would have moved the x over also and said 0 is greater than or equal to x squared minus 9 and factored it like this, which I suggest you do. You're going to see that's the problem from last semester, and you would put this on a number line. So I'm going to put this over here, and you could also put that. Close circles, and negative 3 and 3. Okay, because 3 works. 9 minus 3 squared, 9 minus 9 is 0, square root of 0 is 0. It's an answer. Negative 3 would also work, so you get the same answer. Okay? And now I'm going to test areas and see which ones work. Okay? So if I test negative 4, okay, and I'm going to test it in here. And I'll write like that because 0 is greater than or equal to that. Okay, so if I test numbers in here, so if I test negative 4, negative 4 would make that a negative 7, make that a negative 1, a negative times a negative is a positive. I feel like I did something wrong. I did. I want negatives. This is so confusing. I would probably not do a number line, but we'll just go with it as because I want less than 0. If I pick 0, okay, that would be negative 3 times positive 3, which would be a negative, and I want less than 0, and this would be positive. So the values that work are here. It's so confusing now. If I would have done it from there, it probably would have been less confusing because I would have put the dots and just checked what's the answer. But think about it. Any number like 4 is not going to work in there. 9 minus 4 squared, that's 9 minus 16. That's negative. Can't take a square root of negative. But if I plug in 2, 9 minus 2 squared, that's 4. Square root of 5, I can do that. It's a positive answer. So kind of think about where your different values are and which one would work, and you could write the answer like this. Okay? I know, I think I made that more confusing. Sorry. Let's go on. Okay, this is kind of a double problem. We have a square root and we have a denominator. So we have to deal with both of these. So the square root can't be negative, so I'm going to deal with that first. I know that has to be greater than or equal to 0. Drop the square root value. And the stuff inside can't be negative, so it has to be square root greater than or equal to 0. Okay, move the 4 over. I get x is greater than or equal to 4. And that's all I got. Now in the denominator, 5 minus x can't be negative. So x cannot, or if you look at x cannot equal 5. So to put this on the number line, open circle of 5. We have 4, x is closed circle and greater. So if I was going to write this, I could write it, here's your answer, so all reals, except x cannot equal 5, or x is greater than or equal to 4, which is kind of confusing. Or if I use it in here, I'd be 4 to 5, union 5 to infinity. Better answer. Most of the time it doesn't matter, but that one is a little better. Okay, I'm going to pause the video and come back.